Okay, good morning everybody. This is going to be, I think, 2 videos. We'll probably break into 2 parts, maybe a third, including how to do one thing on the calculator. But this is lesson 3 in Unit 3 of Honors 1. What we're going to talk about today now is the spread of data, how to measure that, and specifically this type of visual called a box and whisker plot, which is going to show us how how a set of data is spread out. Okay, so if you read this first question, I'll give you a second to read this here, but it should be asking things that we covered last class. All right, so what's the idea here? Well, we're looking at these 10 sample Coca-Cola cans. We're measuring how much volume they contain, and we're going to see if Coca-Cola's claims that every can contains 355 milliliters is correct, right? So the GDC, you should be able to do both of these on the GDC. All right, mean, we could do this manually, but that would mean adding these all up, dividing by 10. We could also find the median manually, right? That would be ordering them least to greatest. And remember, for this one, since we have 10 sets of 10 data values, the median is actually going to be the mean of the 2 middle values, which in this case would be the 5th and the 6th values. Okay, but we don't want to do that. We want to let the calculator do that. I'll give you a second to pause this, put that data in, and get an answer. And if my numbers are right here, and I got a full disclosure, I'm using another teacher's numbers, but I trust them. We're getting that the mean, right? The way we indicate mean is this X bar notation, so that's 354.01 milliliters. And the median, which on the calculator, if you scroll down through all the data it gives you when you do one variable statistics, I think it's like the 10th item down. I think it's the 10th, but it'll literally write out the word median, usually X if that's the variable that we're using, and that should be 354.95. So we're going to 2 decimal places with both of these. Okay. So those are the 2 measures of center for this data. And like I said, today we're going to talk about spread. So there are a lot of other statistics that the calculator gives you when you run through that one variable statistics procedure. So you see a display called min-x. That's the smallest value in the data set. All right. Q1, this is called the lower quartile. Q3 is the upper quartile. Max is the max, and then this median, this is actually the same thing as Q2. Okay, and we'll get to what the quartiles actually do with the data in a second. But if we just confine these on our display, and I'll make a video showing this so that you guys can just kind of see what I'm talking about. But here are the numbers that I'm getting if you want to check your calculator's output with what we think it should be. So for the min, and I'm not going to write units here, I've got 348.5. For the lower quartile, 350.2. Excuse me. For the upper quartile, 357.8. And the max value is 360.2. And actually, we should be able to find that from right here. This looks like the biggest value. The min, 348.5. That's right here. Okay? So just stay tuned for what these quartiles mean, right? For a visual at least. So we're going to define 2 more measures of spread. One is range. This one you've probably heard before. All range is it's the difference between the max and the min value. Okay, so literally to find the range, we just take the max value we subtract the min value. That's the range. That's easy. Okay? So in our case, for this data, we would take 360.2, we'd subtract 348.5, and that would give, I believe, 11.7. Okay? So that's 11.7. And again, how are we getting that? We're just taking the max here minus the min. The interquartile range, so basically what you're going to do here is you're going to subtract the upper quartile, which is Q3, from the lower quartile value, which is Q1. Okay, so that would be, in this case, 357.8 minus 350.2. This is going to be 7.6. Okay? So that's 7.6. All right? Yeah, so let's look at the visual for this in a second. Okay? Or right now, I should say. So here's an example, a visual of what really this means. All right. So this is our minimum, right? This is our minimum value. This is different data, but it doesn't matter. You can understand the idea. So the minimum goes here. The max goes here. All right. And then this vertical line signifies the median. This vertical line signifies Q1, which is the first quartile. This vertical line here signifies the Q3, which is the third quartile. Okay, so there's 4 regions here. There's the region from here to here, from this dot to this vertical line. There's a region from here to here, from these 2 vertical lines, Q1 to the median. There's a region from this vertical line here, the median to Q3, and there's a region from Q3 all the way to the max. Okay, guys, by definition of a quartile, every one of these ranges of values, it covers 25% of the data. Okay, 25% of the data. So that's why this is called Q1, is because it separates the first 25% of data from the second. All right. So in this case, it looks like, since this is more, it looks like we have a bigger range of values, right? Of a bigger spread here than here. Okay? So it just kind of tells us about the spread and the shape of the data. So that's what the quartiles really mean. And then the median, right? The median, which is Q2, well, that we've said that that's the middle value, right? So what does it do? Well, it separates the first half of the data from the second half. Okay, and you can see the first half of the data, the range of values are from 1 to 6. It's only, a difference of 5. The second half of the data is more spread out because it ranges from 6 to 15. Okay? Yeah. So if we go back to page 1 and we look at this example 3, well, now what happens if we add an 11th can of Coke and the mean now becomes 355 exactly? What's the volume of the new can? Write a good let statement and show an organized solution. So basically, what we can say, let's let x equal the volume of the new can, right? And we know that this 355 here is going to be the original sum of the 10 cans plus the volume of the new can divided by 11. Right? So that's our equation. That's our equation that we want to solve. And we can say from computing the mean here, well, if this was the mean and there were 10 cans, we can multiply this by 10 to get the sum. So the sum of the milliliters in the first 10 cans would be 354.01 times 10, which would be 3540.1. Okay, so this is 3540.1. Again, that's just the original average times 10 plus x, our new volume, divided by 11. Okay, and then when we could solve this, right, we would take 355 times 11, then we'd subtract 3540.1. You guys have pretty good algebra, so this is going to tell us that x is 364 358.9 milliliters. Let me see if I have room to add milliliters in there. Yeah, let's do that. Milliliters. Okay. Now what this is asking you to do is to go to your data list from the original 10, put this new value in, 364.9, and come up with a new median and a new IQR. So remember, the IQR is Q3 minus Q1. So again, go ahead and pause the video if you want, put that new data value in, and see what you get. For me, I've done this ahead of time, but I get the new median is 355.3 milliliters, and the new IQR would be 358.2 minus 350.2, which is 8. Okay, so that's where I'm going to stop this first video, and I'll see you guys on the next video very soon.